Let's continue to the Do you guys remember all this from entropy? Dallas total. Yeah, actually we'll introduce a new term. The bigger focus factor in the Cambridge syllabus. We'll come to that del G. But are we clear with this, Shabbat, everyone? Do we need to revise anything? Okay. So moving on. Now that's Labib, what you asked. That's bromine molecules reacting there. A small amount of bromine can dissolve in water. Okay, small amount of bromine, ছোট্ট একটা amount dissolve করতে পারে, but large amounts won't dissolve. That's bromine molecules that's reacting there. Anything else? 5 minutes পর আবার question করো, একটু respond করো তাড়াতাড়ি। তখন জিজ্ঞেস করছিলাম, you were completely unresponsive when I was explaining it. Is there anything else? Okay, and Bra is saying, why is there a negative sign in front of entropy change of surrounding? That's the formula. Our syllabus, we don't have the derivation from thermodynamics, but it comes from thermodynamics advanced calculations, which basically our syllabus doesn't cover. Anything else, anyone, from this lecture? Okay, and Cambridge students, তোমাদের আজকে I want to start off with del G. Next class I'll use a separate worksheet for the Cambridge batches, okay? And we'll have like a breakout room where I'll do the Cambridge worksheets alada, okay? Let me just tell you one thing. So when we have this equation, del G, del S total, del S total, at Excel tomorrow they can so the book they mention syllabuses usually don't require you to solve it like this, but it's mentioned in your book. Usually আসে না Excel, but I'm saying আসলে you can complain. But তোমাকে যদি এসব দেখা যায়, আমি যা দেখাচ্ছি, you guys should be able to do it. See what I'm doing? So del S is minus del H by T. If I multiply this equation by minus T, I get minus T del S total is equal to minus T del S sys plus delta H. So কি করলাম? I multiplied by minus T. Are we okay, সবাই? I multiplied by minus T. Are we okay? So this term minus T del S total is called Gibbs free energy change. Gibbs free energy change, named after a scientist who did a lot of work in thermodynamics. So a derivation, it's like physics যখন তোমরা F is equal to mv minus mu by T কে rearrange করে you get F is equal to ma. You get a quantity there, acceleration. Right, so acceleration has its purposes. We need to talk about the quantity. So sometimes these derivations in science lead to new terms, to new quantities, which are important in understanding these phenomena. But when we rearrange it, we get this. So Cambridge, when we go through the book, you'll see I'll go through both books after the chapter is done. Cambridge is like a pointer in the question papers especially. They'll just stop writing cis. They just write this. Cambridge students are entropy question on school. You've done this chapter, so you know what I'm saying? Dictionary question below. So when they write del S, they're just saying change in entropy. So saying change in entropy of what? Maybe the change in entropy of the system, or basically surrounding entropy সারাটা basically এটা কাজ আমরা পরে দেখবো, we'll come back to it, but basically what I'm saying is if a reaction is to be feasible, what did I say that way? For a reaction to be feasible, del S total has to be greater than 0 and del G has to be less than 0. So কেমনে এটা ট্রেন করব? Because if del S total is positive, temperature can never be negative, right? Absolute temperature measured in Kelvin can never be negative, it's greater than 0. So if I multiply a term that is positive by a term that's positive by minus 1, then এই terms are negative হবে না? সবাই বুঝতেছো? Cambridge students especially. So we start off today with Dallas Open. That sets up the chapter. In Cambridge question papers from this topic was introduced in Cambridge in 2016. 2016 again, I don't remember. I never saw a single question with Dallas Open. Thing is though, the idea del G equation is derived from Dallas Open. And your Cambridge book even shows you worked examples from both books, Excel and Cambridge. Did I go through the book, guys? So, when I'm going through the books, you saw in the Cambridge book, you saw that they showed you how we derive, make certain statements or make certain predictions about the systems using Telescope. So, if you have a question about Telescope, you can't complain because entropy discussions always start there. It's always about total entropy change in the universe. So why is Gibbs free energy used? Does it have any further application? As we do more problems, you'll understand, and we'll come back to that later, and I'll do that in a Cambridge specific discussion. But for the time being today, the first two worksheets that I want to do will focus on this idea that overall, the entropy change in the universe has to be positive. Now, the system entropy might decrease. There must be an increase in the surrounding for that change. Something with a negative entropy change of the system, like this one, number 3, might still be feasible because the surrounding entropy increased enough, and vice versa. Clear, Sabat? Okay, so I think the entropy discussion is enough for it. Like the worksheet, but we can have another second round of Q&A after this is done. So you guys keep going. Super. Data book value গুলো বলছিস, give me one. What's the formula? Read the question. By that time I mean data দিয়েছি. Find the entropy of methane from the data. The entropy of methane. The entropy of methane is 186.2. So you will in the exam. None of your data books nowadays have entropy values. Cambridge or Excel. So this is an older Excel paper. So 186.2. So some Kelvin. Units, conventions, sort of those things before we move on to next class. The next class is on R2 different worksheets. Before that, make sure your basic units look here. So they're cracking hydrocarbons here, right? The temperature is given, the del H is given. Calculate the standard entropy change. So del S is equal to Jadil formula sum of entropy of products minus sum of entropy of reactants. When I say sum of entropy of products, I mean you need to take into consideration stoichiometric amounts, the molar ratios. So there's 1 mole of each. So I'm going to jhamala nai. So I get কত guys 266.9 plus 1 significant figure scale রাখো 186.2 minus 310.1 which comes to আমার সামনে মার্কস কিন্তু খোলা আছে comes to plus 143 unit লিখতে ভুলবো না joule per mole per Kelvin. Technically I should write 143.4 since my data was to 4 second figure. ঠিক আছে সবাই? Okay. Don't mess these up, okay? It's Del S Cambridge when you guys get the Del G version of the question. Okay, show Del S style. Okay. What's the sign for your answer as you expected? Okay, so when does entropy of system increase? When solid becomes liquid or liquid becomes gas or solid becomes gas. State change on or in that direction, right? Or when the number of moles, if all of them are all of them in this equation are gases, so the number of moles is increasing. Right, so you'll say yes, it's as expected because there are more moles of product than react. Yes, as there are more moles of product than react, or there's 2 moles of product compared to 1 mole of react. Are we okay? Another reason entropy increases is the state change. Okay, so এরকম simple prediction করতে দিবে আর data দিলে সবচেয়ে ভালো data দিলে আমরা তখন আর guess test করতে চাই আমি just formula বসে answer পেয়ে যাবো next you calculate the entropy change of the surrounding at 700 Kelvin so del S surrounding normally standard বলি আমরা right in the equations but this one is not standard because it's 700 Kelvin so it's minus del H by T so our system minus 71.9 into 1000 divided by 700. I'm converting it to joule per mole per Kelvin. Our answer into them minus, you can keep it in kilojoule per mole or Kelvin if you want, but I'm converting to joule per mole. Joule per mole per Kelvin. Or joule per Kelvin per mole. Then they said, so I did that. Use this value and your answer to explain why butane cracks into propene at this temperature. So I can see my Del S system was 143 plus, and my Del S surrounding is the negative 1 or 2. তাহলে কি আমার Del S total is positive, right? সবাই আশরাফি কোনটা 1 or 3? Saying is 1 or 3? Okay, minus topic into. So del S total is positive. You can show the math if you want, do the calculation if you want. So del S total is 143. I mean class niche bola ami this calculation kore dicche since it's our first worksheet which comes to দেখো তো কত আচ্ছা এখানে plus 40.3 joule per mole per Kelvin. So দেখো আমি দুটোই joule per mole per Kelvin রাখছি I could keep both kilojoule per mole per Kelvin as well. That would also work. When you do del G calculations, Cambridge, how I use the units names. That's it. Okay. So you'll say since del S total is positive, the reaction is feasible. Could be easy question entropy most of the time. But you'll see একটা দুইটা করার পর question pattern গুলো দেখো আমি কি question select করে রাখছি তোমাদের জন্য আমার worksheets গুলো ওকে question patterns গুলো দেখো আমরা Edexcel Cambridge যে কয়েকটা question করবে ওদের next ক্লাসে ওগুলো আমরা যখন del G দিয়ে করব তোমরা just ওদের আর del S পর্যন্ত তো ক্যালকুলেশন করতেই হবে বাট আপনি যেন ওদের সাথে del G নিয়ে let's say the different situations that they show us in that question when they ask us to make predictions about feasibility ওই ডিসকাশন গুলো আর কি শুনবা তোমরা ওদের কোয়েশ্চেন পেপারসও কয়েকটা খুব ভালো ভালো সিনারিওস আছে ওকে নেক্সট আই লাইক দিস কাইন্ড অফ আ কোয়েশ্চেন a lot because some people struggle with this calculate the minimum temperature needed for this reaction to be thermodynamically feasible but spontaneous both mean the same thing del S total is positive or del G is negative if you need to repeat anything if I'm talking too quick you can থামতে বলো okay so when will it be feasible? When del S cis plus del S surrounding is at least equal to 0, right? সবাই মানে 0 বসাও। তো del S cisটা কি? del S cisটা হচ্ছে 143 and del S surrounding হচ্ছে minus del H by T. So minus del H টা হচ্ছে আমার minus del S H by T is equal to 0. So এখন আমার del S surrounding, I'm assuming my delta H won't change. I'm assuming my delta S system didn't change. এগুলো কিন্তু চেঞ্জ করে, একটু সামান্য চেঞ্জ করে with temperature. Saying del H চেঞ্জ করে, হ্যাঁ del H হালকা, একদম হালকা, insignificant, ছোট একটা চেঞ্জ. When they give us data, আমরা quantitatively করব. Other than that, we'll always make this assumption that the del H remains the same. So তাহলে I'm saying কি del H by T is equal to 143. Therefore, T is equal to delta H by 143. Delta H to খেয়াল রাখো is in what unit, and kilojoule per mole is in, and del S is in what unit. So delta H টাকে আমাদের kilojoule per mole থেকে joule per mole নিয়ে যেতে হবে. So I'm going to write 71.9 into 1000 because chip is in joule per mole per day. Are we clear, guys? These are the silly mistakes to look out for. Okay. You guys won't get stuck with the math. The math is very easy, no? Plus minus and a formula just moves to the power of del S surrounding, del H by T minus del H by T. So eগুলো একটু খেয়াল রাখবে, and আমার sin টাইম গুলো খেয়াল রাখবে, like del H আমার এখানে পজিটিভ, that's okay, আমার minus del H T ওইদিকে plus 6, এগুলো একটু চেক করবে যে ভুল করতেছি কিনা। How much do we get? Yes, এখানে they got 5 or 2.8 দেখো তো তোমাদের মিলে কিনা, মানে to see আমার working বলেছি কিনা আর কি। হ্যাঁ 5 or 3, ঠিক আছে। তো এখন 5 or 2.8 is the temperature at which delta T will be 0. একটা ছোট কথা বলবেন। So আমার যদি del S total is equal to del S cis minus del H by T, আমার এটা হচ্ছে পজিটিভ, এটা হচ্ছে মাইনাসে প্লাসে মাইনাস, did you understand that সবাই? এই টার্মটা is minus negative. So I want this to be at least, if this is 143, I want this to be minus 143. That will be exactly 0. But for it to be feasible, the del S total usually is going to be greater than 0. You're saying, what are you trying to tell us? I'm saying আমাদের এই equation we got to 5 or 2.8, but এটা হচ্ছে সামান্য একটু বেশি লাগবে। Maths গুলো করো না, find the minimum value for something to be, like when you do inequalities. I don't want to get into inequality today because I don't have to do it ওভাবে, but তোমরা যারা inequality দিয়ে করতে চাও, you could have made this an inequality sign, এই যে equal to. You know what I'm saying when I'm talking about inequalities? You treat inequalities just like equations, right? So ব্যাপারটা ওরকম আর কি, the temperature here, if you're saying আমি inequalities পারি না, আমি ওই স্টুডেন্টের জন্য বলছি যারা পারে না, you need to understand that what this means. যদি MCQ আসে তোমার, এটা যদি MCQ question হয় Alexa, and তোমার option হচ্ছে 502 or 503, we'll go for 503 because এর চেয়ে বেশি যদি হয় temperature, if the temperature becomes higher, then this will become less negative and the overall sum will be positive. Are we clear? Cambridge আমরা next worksheet-এ, next class-এ করব, একই জিনিস করব with del G. শুধু del G-র কাজে কি বলবো আমরা? It has to become more negative. Okay, Anika is asking, what about kinetic? What if it says kinetic stability? Kinetic stability is something else. Kinetic stability is related to activation energy. That has nothing to do with entropy. ওটা হচ্ছে basically ধরো, the entropy is basically telling us about the equilibrium position. When this reaction starts happening, once it has enough activation energy, will the reaction go to completion? বুঝছো, like methane and oxygen যদি আমি পুরাই, is it going to burn away completely? Yes, it's going to burn away completely if I give it enough energy. like বাসায় গ্যাসের চুলায়, there's no gas left after the reactions, when the reactions happen. It's not like we have gas roaming around in our kitchen because it reaches an equilibrium where it's 50% complete, right? So that's what we are answering here, Anika. Okay, we are answering how far the reaction will go in terms of equilibrium position, right? And kinetic stability হচ্ছে যখন তোমাকে জিজ্ঞেস করবে যে ঠিক আছে this reaction is feasible, যেটা হচ্ছে না কেন, because you don't have enough activation. Okay, why I took exactly 0, Labiba, is because I know for something to be feasible, the del S total has to be at greater than 0, মানে কি, it has to be positive. তো আমি ক্যালকুলেশন করার সময় আমি এখানে +1 ধরতে পারতাম, আমি এখানে +2 ধরতে পারতাম, আমি এখানে +3 ধরতে পারতাম, but they asked us what's the minimum temperature needed for this reaction. So when they asked us what's the minimum temperature needed, minimum যদি তুমি যদি এই টেম্পারেচার নাও যেটা আমরা বের করছি 502, del S total will be exactly 0, right? So তুমি যদি এই টেম্পারেচার একটু হায়ার করো এই টেম্পারেচারটা, সে 502 না নিয়ে তুমি 502.8 না নিয়ে তুমি 502.9 নিলা, তো তুমি যদি 502.9 নাও, this value is going to become positive. So this is the bare minimum needed to reach at least 0. বুঝছো? Treat it like an তোমার যদি ইকুয়েশন দিয়ে বুঝতে ডিফিকাল্ট হচ্ছে, তুমি এই জিনিসটাকে এভাবে করতে পারো, +143 minus del H by T greater than 0, and then solve for T. ঠিক আছে? So inequality দিয়েও করতে পারো if you want. Clear সবাই? So we'll get this question often. They'll ask us, there's another worksheet like this, I can deep on the next class, where they'll ask us to predict whether a substance can be stored at room temperature. তোমাকে যদি বলে যে can so and so chemical be stored at room temperature, তখন তোমার বের করতে হবে যে at room temperature is this reaction feasible or not, right? তারপর তোমাকে যদি জিজ্ঞেস করে যে let's say why does water melt at 0 degrees, তখন তুমি ক্যালকুলেট করে বের করতে পারবে যে এই টেম্পারেচার রিঅ্যাকশনটা মিনিমাম টেম্পারেচার feasible. Like think of যে Labiba, তোমার কোয়েশ্চনটা is related to what I'm going to say next. Think of, আমি যদি তোমাকে বলি what's the minimum temperature needed to melt water, 0 is the minimum needed to melt water, right? But আমি যদি 10 degrees দিয়েও তো মেল্ট করবে, 20 degrees দিলেও তো মেল্ট করবে, কেন? Because when I make it 10 degrees or 20 degrees or 30 degrees, I'm increasing the temperature, and that will make the del H total more positive. When I'm making these comments, always back it up. তুমি যখন এগুলো করবা, when you guys are practicing, when you're thinking about these things, okay, those of you who are thinking about it properly, always back it up with the equation. মানে what I'm saying is this stuff. এখানে ওই দিন যে কথাগুলো বলছিলাম না, temperature lower হলে it's feasible, temperature higher হলে it's feasible, you will never memorize this. Always work out করবা পরীক্ষা দিতে, ছোট রাফ ওয়ার্ক করবা, যেরকম আমি মাত্র করলাম পরীক্ষা করার সময়, কোয়েশ্চেন পেপার ব্ল্যাঙ্ক স্পেস কোনো থেকে রাফ ওয়ার্ক করে বের করবে, নেভার মেমোরাইজ। এখানে সিলি মিস্টেক করো। আমি ওকে সবাই? So number B, the aluminum oxide behaves as a heterogeneous catalyst. Explain both what is meant by the term heterogeneous, so different phase compared to the reactants, and how in terms of activation the catalyst is able to speed up nothing. So heterogeneous is in a different alternate route. So it's a lower here alternate route. So a greater proportion of particles, of molecules in this case, of particles have the minimum let's write it like this, have energy greater than or equal to EA. Just throw in one more line since we're realizing. So rate of effective collision. So rate of effective collisions increases. You know what I'm talking about? As we do these worksheets, it's not going to be just entropy. There's a whole spectrum of scenarios. A Cambridge batch, some of your best questions in entropy are linked to transition metals. So ওগুলো আমাদের আরেকটু পরে করতে হবে। ওগুলো আমরা question paper sessions এ করব। So some of your best questions are linked to transition metal complexes and all that. Even at Excel there আসবে unit 5 এ যেরকম। So ওগুলো transition metals এর পর আমরা করব। এখন let's just finish up our ideas of entropy before we move on. There's another question. Why doesn't the heterogeneous catalyst get affected by pressure much? What do you mean? Anika, is there a specific question that bothers you? কোনো question paper বা বইতে কিছু দেখছো? হ্যাঁ বলো তো, can you tell me the exact words they said there? Something's missing তোমার স্টেটমেন্টে। আচ্ছা তুমি বের করো, ঠিক আছে বের করো, আমাকে জাস্ট একটু তুমি গ্রুপ চ্যাটে লেখো। হ্যাঁ হাফ হাফ বললে পারবো না অ্যান্সার করতে, একটু tell me what the question is, okay? Type it out. Guys, যাদের হয়ে গেছে move on. So this one is about enthalpy changes, ছোট experiment. Okay, so I'll try to give you a good mix of all these questions. একটু তাড়াতাড়ি করো। একটা জিনিস আনিকা, যেটা তুমি লাস্ট লাইন বললা স্যাচুরেটেড, এক্সাক্ট কোয়েশ্চেনটা বলো, I can give you a more specific answer তখন, but maybe you're referring to this এই scenario যে তোমার when you have these reactions happening on the heterogeneous catalyst surface reaction হয় না, তো catalyst surface যদি reaction হয়, তোমার what happens is তোমার catalyst এর active site বলে একটা জিনিস থাকে, not just enzyme, even inorganic catalyst like iron and Haber process or কিছু active site থাকে, মানে ওই catalyst এর ওই জায়গায় গিয়ে রিঅ্যাকশনটা হইতে হবে, ঠিক আছে? সো catalyst এর একদম বরাবর ওই জায়গায় গিয়ে রিঅ্যাকশনটা হইতে হবে। সো if you think, so what happens is when you have too many reacting molecules, তখন ওরা ওই সাইট গুলোকে সব লক করে ফেলে আর কি, মানে তোমার জায়গা থাকে না। ধরো আমরা যদি একটা let's say if you go to a customer service center, say GP বা একটা ব্যাংকে, তোমার ওখানে কাস্টমার সার্ভিস বুথ 6টা আছে, তো মানুষ হচ্ছে আমরা 50 জন, তখন কি হয়ে যায় একটা পয়েন্টে they can't serve everyone at the same time, they can only serve 6 people at a time, তাই না? কারণ ওদের 6টা বুথ আছে, তো ক্যাটালিস্টের ওরকম একটা ব্যাপার হয়ে যায়। That's when we can say that it gets saturated with reactants, because তোমার এতগুলো রিঅ্যাক্টেন্ট আছে তোমার, যে তোমার enough catalyst নাই তখন রিঅ্যাকশন করার জন্য। So how would you increase the rate of that reaction? You would increase the rate of that reaction by having more catalysts. Like a service center, they should add more booths, আরো 10 জন মানুষ বসা যদি এত রাশ থাকে, ওরকম আর কি। That's the concept there. But exact questionটা দেখো, because তুমি আগের লাইনটা লিখছিলা, why doesn't it get affected by pressure much? Catalyst is not affected